This video is going to cover the topic of area and circumference of circles. Be sure the date and topic are at the top of your page. The essential question for this video is how do we calculate the area and circumference of circles? And this video should serve as a very quick refresh. We'll start with a few reminders of vocabulary. We'll start with circumference, and circumference is the measure of the distance around the circle. It's kind of like perimeter, but specifically for circles. So while circumference is around, area is the measure inside a circle. The diameter is the distance across the middle of the circle. The radius is from the middle to any point on the circumference, right? It's a measure of that distance. And lastly, pi, which we know is a very specific measurement, and we usually use the approximation of 3.14. Sometimes we write 22/7. We often write it with our pi symbol. But what it really is a ratio of the circumference to the diameter of the circle. And what's amazing is that the ratio of every circle's circumference to diameter is exactly the same. And that is that for each one of our circles, the circumference is about 3 times larger than the diameter. It's pretty amazing. And what that means is that if we know the diameter of a circle, we can multiply it by pi, or about 3.14, and that will always tell us what our circumference is. So for example, if we know that the diameter of this circle is 5, I can just do 5 times my approximation of pi, and that will tell me my circumference. It's just like equation solving. So I'll go ahead and do that. And that would mean the distance around this circle would be about 15 7/10 centimeters. And I have my units in there always. And of course, if we know the radius, then we have to take an extra step first, because we need to know, first of all, what the diameter is. I'm just going to kind of extend this line across. And I know that this would mean my diameter would be 6 centimeters, right? So once I've doubled that, I can go ahead and say, oh, okay, it's 6 times pi will give me my circumference, which means the distance around this circle is about 18 84 centimeters. This also means that sometimes we can work backwards. So if we know the circumference of something, let's say the circumference of this circle is 31 4/10 centimeters, but we don't know the diameter, we can work backwards and say, oh, well, 31 4/10, is equal to our diameter times pi, and we can divide both sides by pi and find out that our diameter is 10. We could also go a step further and then say our radius would be, hopefully you're all thinking it alongside with me, would be 5. And that's just basic backtracking, or you could think of it as equation solving. Pi is also used when we're calculating area of circles. And as you may remember, a square, let's see if I can kind of sketch this for you, a square that's made from the size of the radius fits inside the area of the circle 1, 2, about 3 times. In fact, it's just a little over 3 times, and it fits 3.14, or pi, times. So it fits pi times inside there, and that's how we use that formula, an equation, to solve for the area of a circle. So to solve the area of a circle, we know that the area is equivalent to the radius square times pi, or you'll more often kind of see it in this order, pi times the radius squared. So if we want to find the radius, or the area of this circle, right, we know the area is the value we get when we multiply pi times that radius square. We just fill in what we know. So we know that pi is about 3.14. We know that our radius is 3 and it needs to be squared. Right? And so then we just use our PEMDAS and solve until we get to our final answer. And it's 28 and 26 hundredths, and this time we do the units of inches squared, right? Even though it's a circle, we still count the number of squares inside. So there's almost 28 squares that fit inside here, just a little bit over, 28 and 26 hundredths of another square. If we're looking to find the area, but we are looking at a circle and we only know the diameter, that just means we have to find one extra step, right? So if the diameter here is 14, what we actually need is the radius. So we just have to cut that in half. The radius would be 7 feet. And then we just move on as we would normally. The area is pi times the radius square, and we'll fill in what we know and solve. You can go ahead and try that. I'll do the same thing, and then we'll make sure we have the same answer. How do we do? Hopefully we all have the same answer of about 153 and 86 hundredths feet squared. So that's how many little square feet there are inside that circle. And of course, sometimes we need to work backwards where we maybe know the area, but we don't know what the radius was. So if I tell you that the area of this circle is 78.5 square inches, hopefully we know we could work backwards to find our radius, right? So we'd fill in what we know. 78.5 goes over here. We certainly know pi is still about 3.14, and we would multiply that by whatever our radius square is. Now we don't know what that is. We're going to solve, just like we do normal algebraic solving, divide on both sides. And you'll get to a point where you find out that the radius square is 25. Now to undo that, you can think about it in a couple ways, right? You can kind of just think about it logically. If there's some sort of square here and it's 25 on both sides, or 25 total, you know that it probably is 5 on both sides. You can also think about undoing the squaring by doing the square root, right? So that would leave us with r on this side, and then you think to yourself, what times itself makes 25? And the answer is 5. So that means the radius is 5 inches. So I'll leave you with a circle here that is 12 inches in diameter, and I want you to make sure that you can identify all the parts. So go ahead and record what the diameter is. That should be a given. Make sure you know what the radius is based on that, and then calculate the circumference and the area. And bring those calculations with you to class. And remember, the essential question of this video was, how do we calculate area and circumference of circles? This was a quick overview. I know we've practiced in the past. I'm sure you've done work with this before. So hopefully this just kind of jogged your memory just a bit before we work with it more and with more in-depth strategies and questions moving forward.